You will go to measuring galactic distances. You click on preview or take the quiz. And it's only 4 questions, and the table is very small in comparison with, and then you have the questions here, in comparison with the table given here, where you can actually understand what's going on. So you still need this table to work on the lab. You can do this on a separate piece of paper or in Excel. And then you just have to fill in the results. But you have to really pay attention how to do this, okay? So the lab starts here, basically. Well, you need this equation, but mostly here. Okay. Okay, this graph plots absolute magnitude with period, the log. What you should know from variable stars is that it's a very nice method, an effective method to determine the distance between stars, very far stars. A variable star, like a Cepheid variable, is a type of star whose luminosity is changing periodically. It can be because of fluctuations, between the outer layers and the inner layers, pressure and gravity being unbalanced, but it has a nice period. Some Cepheid variables have periods of almost a year, where the luminosity goes from the peak to the bottom, right? So we use that, and we can determine the distance using this equation here. The absolute magnitude is given here. And be careful because it's negative. The +5 is a constant that we use due to extinction. For example, dust. The apparent magnitude, you are going to find it on the table. Here, you see? And then you will divide this by 5, and you do 10 to the power of this exponent here, and that will give you the distance to that Cepheid variable, to that star. Now, I want to show you one example. And so far, yeah, this is a non-stellarium lab. You don't need a stellarium for this lab. All that data is given here. M101 is a very far galaxy. You see, we measure the distance in megaparsecs, which is 1,000,000 parsecs. The accepted distance is 8. You are going to find the average of 4 based on 4 measurements. These are the Cepheid variables that you use. This is the period. And then you are probably wondering, how do you do this? Well, you're going to use a calculator, or you can use Excel. In the calculator, I believe there's something called log. Here, you see the log there, the bottom? So you can put 58.54, take the log, and it gives you a value, 1.77. Goes here. Now, why do you need to take the log? Because the plot is in a log base, at least the x-axis. You're going to use the log of the period, 1.77 is around here, and you're going to use a ruler. I'm going to try to use a shape here to find the corresponding point for the absolute magnitude, which will be there. So my absolute magnitude, minus 5.5, minus 6, minus 6.5, minus 6.3 approximately. So that value will go here. And you have all the values that you need to find the distance using the equation. So let's use Excel. So you see how you have to do this. Now, you don't have to do You don't have to show me or submit the Excel file, but you can use it to do your calculations. All right. So let me show you how you will do that. You can do it by hand as well, like I just did. But I think Excel will help you because look what you can do. So let me open Excel. And that's it for the lab, by the way. That's basically what you have to do. One thing, guys, while I'm doing this, okay, a parenthesis, two things. I want you guys to complete the evaluation for the course. I think they already submitted the, what you have to write, what you think about the course. So I want you to do that. The other thing is that if you know people who is going to take astronomy during the summer, please tell them do not, but they should be taking the classes that are remote live. At least I feel like astronomy cannot be done like just fully online. Doesn't really work.
Professor,
Right? Yeah.
for lab class, you can't take the evaluation.
There should be. They sent me an email about it.
I only see my other 5.
As soon as you get it, then they might send it to you soon.
Okay.
All right. Let's put this like this. This is how you want it. Again, for the summer, we have. I don't know for what reason people are not enrolling on the remote lives. They are going to online. Online, honestly, I hear so many complaints, and it's because it's not the same. And new students don't know, or some students who may think that it's easy. It's not. It's harder. Online is harder because you don't really learn much. Imagine if it's so hard to do it like this. Imagine how hard it would be if you were doing this by yourself, though. So if you know people who want to take astronomy during the summer, suggest them to take it remote. Okay. Anyway, so here it is, right? I'm gonna make it bigger so you can see it in the center. Okay, so that's the p-value, the period given in the lab, right? That's what you're giving in the lab. The next column is the log of this, log of p. So in Excel, you can do this, equals log of what? Of this number. And then this does it automatically for you. There you are. So you see, I already did the third column. Then this, you can copy. Let's do for 1 star. So the apparent magnitude in visual is 23.82. How am I gonna get the absolute magnitude? Well, I'm gonna use this value, 1.77, 1.76, 77, and I'm going to locate it here, like I did. So it's here, right? So so that's why I use this shape. You may wanna use a ruler, okay? But you can always use a pen. 1.77 is an estimate. 1.75 is around here. 1.77 should be around here. So I trace a line, another line. Actually, it's almost in the middle, right? So 6.3, 6.25, okay? So that value that I found for 1.77, that will go here. So I put here absolute magnitude, what did I say? Minus 6.3. All right. Now, I have m, I have little m, I need these two actually. So how do I find the distance? Okay. The distance is found by doing 10. Let's use notepad. Okay. I use 10 to the power of little m minus big M plus 5, all divided by 5. But you remember, this is, right? That. This equation. So what's m minus m? N minus m. So you're going to use a calculator. I want to do 23.82 minus 6.3 becomes positive. So 23.82 plus 23.82 plus 6.3 is 13.12, right? That's this part of the equation. Then I'm going to add 5. That's all this. Then I'm going to divide by 5. Now I need 10 to a power of 7.04. In here, I use this button. I get 10,568,175 parsecs. So you're not going to write that number here. You have to divide this number by 1 million. 10.56. There you are. So my distance is actually 10.56 megaparsecs. It's a highly mathematical lab. You're going to do the same for all of this. And you're going to, well, first for these 4. You're going to find 4 values, right? These 4. You're going to find the average. This one is the average of the first 4. This one, this one, this one, this one. And then you're going to compare it with 8. The larger, the farther a galaxy, the farther, no, this is not that lab, sorry. So you're going to find some errors here. You have to use this equation. Measured will be this minus accepted divided by the accepted times 100%. That will give you the errors. And that's it. The lab is basically this table, guys. All right. How will you do this in Excel? So let's suppose I want to do this value in Excel because I do this with a calculator. So I can do this. 10 to the power of parentheses, another parenthesis, m minus, okay, this will be like that. 10, 10 to a power of this minus this plus 5 divided by 5 plus parentheses. Let's see if I get the same. Yeah, look at that. But actually, remember, I have to divide everything at the end. So all this divided by 1 million. There it is. If you know Excel, you're going to be able to do this in less than an hour. You just have to make your measurements of the second star, for example, is 23.87, right? So you'll put it here, 23.87. How do I find the absolute value with this? 1.62. So you go back. 1.62 should be around here. So you have to find the absolute magnitude. You put it in here, you use the formula, and you find the distance. Remember that whatever you find, you have to divide by 1 million. So you can put it in megaparsecs. Are there any questions? No stellarium, huh? It's one of my favorite labs, actually, this one. It's a very nice lab. Any questions? Really, that's it? Well, I have 2 students who already did this lab. This lab is due on Wednesday, guys. This on Wednesday we're doing another lab. The last lab we're doing it on Wednesday, which is expansion of the universe. All right. It's fair. There's no stellarium. You just have to do the lab. The lab is what you have. It's like a science lab that you will do in a lab, like physics or chemistry, right? You're giving the data, you do it. Okay. So no questions. Are you sure?
Would it be fine if instead of using Excel or something like that, we just print it out?
Yeah, you can use paper, you can print it out, you can use calculator. You don't have to use Excel, guys. In fact, I already
Okay.
told you that submission online, you don't have to put all the table. So unfortunately, I won't be able to see your mistakes. You have to put the final value only. So,
Okay.
okay,
So
and then
we
answer the
still
question.
have to like fill out everything on the like quiz.
Huh?
That's like if we just do all of the questions that are on like the quiz and Canvas for it, would that be fine too? Instead of just like printing it out and then taking a
Yes,
picture
yes,
of it?
yes, of course. But remember, to answer all these questions, you need to complete this table anyway, because
Yeah.
the results are from here. To
Okay.
find the value D, so the submission online is only this part of the table. It's only this. All
Okay.
of these have not been added, but you need this to find this.
All right.
Mhm. So Wednesday is due, guys. It's a half lap. It's only 50 points. The last two laps are half laps because they are very short. Yeah, you don't need a stellarium for this. All right. Any questions? Come on, guys. Have to ask.
I don't have any right now.
So,
Yeah, it doesn't seem
Professor,
like. Yeah.
Professor, this is Sarah. So this lab is gonna be due midnight tonight.
No, midnight on Wednesday.
Oh, so you changed the due date?
Yeah, I mean, I'm not gonna make a lab due the same day though.
Oh, okay, okay. Yeah, I was just
There's
wondering because
two
I
students
saw.
who have finished it already, so I think that's why one of them is not here. So
Okay, and also is the sky chart lab was that always a
extra credit.
what's it called, extra credit?
Yeah, I can extend it. You guys want to keep giving it a try?
Yes, please.
There's another extra credit, a video there. There's two extra credit labs.
Oh, which ones are they?
The Michio Kaku video and this one, the sky chart. I want to extend this
Oh,
to June 2nd, okay?
okay, thank you.
Who did this? A person who did this lab already. If you don't mind, I'm gonna open it, okay? Who did this already? Okay, let's take a look. Yeah, that's the problem with the Orion. Like Orion constellation is up. Thing right now, it's if it's there, it's easy to spot. But it's extra credit, so that's okay. So there are two labs for extra credit, okay? Okay, no more questions. Not yet. It's only 4 of you. Oh, by the way, the final is next week on the 5th of May. You have to do presentations based on your paper. Okay? Let know your classmates, because if they don't do the final, they won't fail, but they will get really, really low grades. Okay, I'm taking a look at this right now. This is cheating, right? Removing the atmosphere, but
Professor,
yeah,
could you go over the like first equations in this lab again?
the first equation.
Yeah. Or like how you get like the log 10p, the MV, and then the D in the table.
Okay. By the way, Orion is up at between 7 and 8 p.m. every day. You want to know how to use it or how you get the values?
how you get the values. Kind of
So
confused.
this one, you can use the calculator. If you have a calculator, that will be easy, right? You use the 58.4, 54, sorry. You take the log, and that will give you the number 1.77 that goes here.
Oh, so just plug in the 58 and then log.
Yeah, but then that log, which is 1.77, you will use it in this table, in this chart, to find the corresponding absolute magnitude.
Okay.
And I estimate it to be minus 6.3, right? So that will go there. If you have the little m and you have the large M,
Mm-hmm.
you can find the distance using the formula. You want to do it, like, suppose this was my pen and paper.
Yeah,
10
yeah.
to a power of little m, and so here you will put by hand, right? 10 to the power of, two parentheses because it's divided by 5 there. 23.82 minus is plus 6.3 plus 5. You add all that, then you divide by 5. So in the calculator, you have to do it step by step. Please do not do it. Do not put everything in the calculator. You have to do it step by step. If not, it's gonna mess it up. There. So you get, this is the exponent. Then you do 10 to a power of that.
Mm-hmm.
But that's not enough. You have to divide that by a million. 10.57 is the answer.
Okay.
Megaparsecs.
And then what are the like two that are after it in some of them?
What two?
It says like the common average D and percent error.
The average will be the average of these three. So each galaxy has 4 Cepheid variables.
Yeah.
You're gonna take for the M101 the average distance to the 4 Cepheid variables.
Okay.
Right in here. And then you're gonna compare it with this. The same for the next 4, for the next 4, for the next 4.
Okay.
So Sarah, do you have any questions? Jennifer? So 2 things, right? Final next week, revision of the course, like evaluation, if you could do it whenever it's available. And summer, if you know of anybody who is interested, let them know that remote classes are available. We have really low right now. I don't know why, to be honest. It's just we want to revamp astronomy. We want to make it that people. We used to have so many students before. Now I feel like students are finding it too hard. I don't know why. So is it clear?